See a Stoke's law. In this law, suppose there is a fluid like this, you have taken liquid, and there is a small spherical body of radius r. So, the radius of this body is equal to r. When this body is falling down with the velocity v, the layer which are touching this spherical body comes into motion. So, these layers, whatever the liquid is here, that comes into motion. Because of the relative motion between the layers, a dragging force acts on this body, that is upside F. According to Stoke's law, dragging force acting on this small spherical body falling through the liquid is given by F is equal to 6 pi eta r v, where v is the velocity of the spherical body, eta is the coefficient of viscosity, r is the radius of the ball. Now, 6 pi is here constant. This formula again can be derived using dimensions.